Now let's draw some connections between the term 0 of a polynomial function and root or solution of a polynomial equation. These three terms are often used incorrectly, so I want to make sure you're clear on the vocabulary. If a polynomial function, we have one that's f. If f is a polynomial function, then the values of x for which f of x is equal to 0 are called zeros. Those are called zeros if they make the function equal to 0. These values of x are called roots or solutions of the polynomial equation. Okay, so we have zeros of a function, but solutions of an equation. Now, each real root of the polynomial equation appears as an x-intercept of the polynomial function. That should make a little bit of sense, but you might want to process that. To find the zeros of a polynomial function, set f of x equal to 0 and then factor. Set each factor equal to 0 and then solve, and that will tell us what those zeros of the function are. The solutions of the equation will be the zeros of our function. Now we have a couple of facts we need to make good note of. Zeros and factors. If x minus c, that could be x minus 1, x minus 7, whatever, is a factor of the function, then that means x equals c is a 0 of the function. Now we actually use this quite often when we're talking about rational functions, finding domain, when we're solving quadratic equations. We use this a lot. Now conversely, if x equals c is a 0, then that means x minus c is a factor. That's useful when we're trying to build a function. The last thing we have is if x equals c is a 0, then f of c equals 0. That is because zeros are, by definition, values that make the function 0. That's actually why they are x-intercepts, because if you're at c comma 0, that's on the x-axis. Now, when a factor is repeated, so say you have x minus 2 times x minus 2 times x minus 2, the power on that, so if x minus 2 appeared 3 times, it would be x minus 2 cubed. Just for example, if we had something like this, the power is called the multiplicity. And that tells us something. It tells us what the behavior is at that point. If the multiplicity of a 0 is even, then the graph will touch the x-axis and turn around. So it will look something like this. It'll touch and turn around. Or it could do the same thing but coming from below. So if a multiplicity is even, it's going to look something like that. It's going to touch the x-axis. If the multiplicity of a 0 is odd, then it will cross through that 0. So let's say these two zeros are odd multiplicity. We would cross right through or cross back through the other way. We'll use these facts as we go forward to graph some polynomials once we find their zeros.